what to do with this. I see a quadratic under a radical. I want to do a trig substitution, but it's not in the right form. So that's when I think complete the square. So in order to complete the square, I must have a positive 1 in front of the x squared. So I'm going to take the time to pull out the negative from the x squared and from the 2x term. Okay, so now I'm going to complete the square on this. So I carry this along, and I'm going to go slow. So I'm going to take half of this thing, which is -1, and square it. So there's a plus a 1. Oh, but then there's this weird thing. I really subtracted a 1, so I need to add a 1. So this turns into x minus 1 squared, right? That's the square. And then plus this 1. When I put it back inside the radical, I'm going to switch the order so that I always have the negative in between. So this is 1 minus x minus 1 squared. Okay, now I'm expecting a trig substitution because that's why I completed the square, because it's inside the radical. So now I'm going to suggest that you do an easy u substitution next. So let's let u equal x minus 1, du is dx. So I get du square root of 1 minus u squared. Oh, I can clearly see that this is an inverse, or this is a sine trig substitution. So du is cosine theta d theta. Okay, let's do it. So cosine of theta d theta, and then what happens down here? Square root of 1 minus sine squared theta d theta. And then I'm going to rewrite this, right? You know that this, let me just go slow here, cosine of theta. This gives me the square root of cosine squared of theta. What? This turns into cosine of theta over cosine of theta. What's going on? It's just the integral of 1 d theta. What happens then? So I end up getting the answer of theta. Well, plus a c. So how do I solve for theta? I can take this, right? So u over 1 is equal to sine of theta. Take the inverse sine of both sides. And so then I put the u back in, and the u is x minus 1. So x minus 1 is theta. So this is inverse sine of x minus 1 plus a c. Okay, so sometimes the easy ones is kind of makes you feel like it's simple stupid, because there's nothing, not like the other ones. So anyway, all right, let's try this one. So this has a radical, but there's not a square inside the radical. So I'm not thinking trig substitution. I'm going to try tricky u. Tricky u is where I let u equal to more than I usually do, not just the inside. So I'm going to let u equal root x plus 1. It could be done in different ways. I'm just going to suggest this. So then, but remember tricky u, you kind of sort of solve for x before you take the derivative. So this one, I can solve for x, right? Okay, now let's take the derivative. So the derivative gives me 2u du equals dx. All right, so I'm going to take out dx and put in 2u du, right? That's what the numerator is. So in the denominator, I've got, well, the square root thing, that is u. Oh, what am I going to do with this x? Oh, there it is. U squared minus 1 is x. So u squared minus 1. All right, so let's see if there's some simplification I could do. Yes, I can cancel the u's. So I end up getting 2 over u squared minus 1. Wait a minute. That factors. Since it can factor, I know I can do partial fraction decomposition. So I get a over u minus 1, b over u plus 1, multiply by the denominator, right? U minus 1, u plus 1. So I get 2 is equal to a times u plus 1, b times u minus 1. We have two good numbers to plug in. So I can let u equal 1, And so that gives me 2 equals 2a. Oops, sorry. A is 1. And if I let u equal -1, I get 2 equals -2b. B is -1. Okay, so I'm taking this, right? And I'm going to bring it up here. Oh, and I need to keep what the u is equal to, right? So I did keep, let me write that down right now so I don't forget. The u is equal to root x plus 1. So what I've got right now is that this turns into a, which is 1 over u minus 1, and then a minus 1 over u plus 1, with a over b, wait, yes, okay, du. Now I'm ready to take the antiderivative. That's easy. They're just ln guys, right? Okay, so I get ln u minus 1 minus ln u plus 1, and then I put the u back in, and the u was equal to the root x plus 1. So this gives me ln root x plus 1 minus 1 minus ln root x plus 1 plus 1 plus c, just for kicks.